Okay, so first things first, just like rational expressions yesterday, the first thing that we need to do is find the restrictions. Okay, so let's work with the bottom here then. So the first restriction here is x can't equal what? 7. What about here?
0.
No.
7.
Okay, 7 again, right? If 7 times 2 is 14, 14 subtract 14 is 0, so the only one that we have here is 7. Okay, so there's our restrictions. Now, here's the difference between a rational expression and an equation outside of just the equal sign. In a rational expression, I was trying to get the denominator to be the same, and I would work with the denominator and the numerator. Today, what I'm going to do is I'm going to get rid of the denominator as soon as I possibly can. Okay, so I can do this one of two ways. I can find the common denominator and multiply everything by the common denominator. Or if I really don't like the way I do that, I would multiply everything by what's on the bottom here to do this, to get rid of it. So this guy right here, I'm going to switch it. And I'm going to change it to this right here. Like that. Okay? So I factored out my 2. Right? Left me with x subtract 7. Okay? Now looking at the denominator right now, what is the common denominator for these three expressions? Yes, it is. Okay? The common denominator is 2 times x minus 7. I have an x minus 7 here, I have a 2 here, and I have a 2 times x minus 7 there. So if you look at it, that's the common denominator. So what I'm going to do next then is I'm going to multiply everything by the denominator, the common denominator. Because then what happens is I end up canceling out my denominators and I can simplify the tops. So let's do it like this now. So I've got x squared plus 25 times 2 times x minus 7. All that is over x minus 7. Plus x add 5 times 2 times x minus 7. All over 2 equals, I'm going to factor this top part here. Okay, so I'm factoring it. What are the factors of 2x squared? 2x and x. All right, now I need the factors of 9 that's going to add to give me 12. So if I go...
No, it's in factors of 18.
Yeah, it'll be, yeah, it is factors of 18. Okay, so just give me a second here. I'm going to think this through. If that's 3 here, that's 6. I don't think I can factor it. I don't believe it's factorable, actually, because I would need the factors of negative 18 that add to give me negative 12, right? And there's no factors of negative 18 that give you negative 12. 6 and 3 and 9 and 2 are the only factors. I can't get 12 out of it, so I'm going to leave it as this. But I'm going to multiply it also by 2 times x minus 7 over 2 times x minus 7. So now here's the difference between yesterday and today. Okay, so what I've done is I've taken my common denominator here and I've multiplied each individual expression by it. Okay, so what happens when I multiply it by it? Well, I have this and this, that cancels, right? That cancels. And that cancels. So now I've gotten rid of my denominator. Alright? So, I see some confusion in this group. So let's look at something a little more simple then. Okay? Let's take 3 over x plus 2x squared over 4 equals 8. Okay, so just looking at that right there. Okay? What would be the common denominator here? 4x. Right? If I don't know what it is, if I can't figure it out on my own, I just multiply it together. It might not be the lowest common denominator that we have, but it's still a common denominator. So I would times this by 4x, this by 4x, and this by 4x. Right? Which gets rid of the 4 here, the x here. And then I would solve it because I have no denominators anymore. All right, so this is still causing a little bit of grief here. So let's look at this one again. Okay, what was it? 3 over x plus 2x squared over 4 equals 8, right? I want to get rid of the denominator. I don't know a common denominator. I have a hard time with this. So the first thing I'm going to do is times everything by x. I'm going to times this by x, and this by x. That gets rid of that. So what am I left with? 3 plus 2x cubed over 4 equals 8x. Now, I want to get rid of the 4. That's the next thing. So let's multiply everything by 4 now. So I times this by 4, this by 4, and this by 4. Okay, that cancels. That leaves me with 12 plus 2x cubed equals 12x, and then I'd have to get it equal to 0 and somehow find a way to factor it or do whatever. Okay, so it's not 32x. Okay, so if you don't like the way I did this with the greatest common factor for my denominator, my common denominator, then just do each individual one. Times everything by x minus 7, x minus 7, x minus 7. If you want, it doesn't matter. Okay? So at this step right here, now I got to multiply across the top. So I get 2x squared plus 50 plus x squared minus 2x minus 35 equals 2x squared minus 12x minus 9. Okay? So what did I have left here when I canceled the x minus 7s? 2 times this. There it is. 2's canceled, x minus 7, x plus 5. All of it canceled, just left me what was on top. Now move everything to one side. Get it equal to 0. So subtract this. Well, that and that's going to cancel when I subtract. It's going to leave me with x squared. Okay? I'm going to add 12x over to here, plus 10x. Okay? And I'm going to add 9 over to here. Equals 0. All right? So now I have a simple quadratic equation that you need to factor. What is it? X plus 12, x minus 2 equals 0. X is equal to negative 12 and 2. Now, in theory, you should pop these back into the original equation and check your solution. But as you can see, there's a lot of work already. But if you have time, you should be able to pop this into the equation and simplify it, and you would get the same on each side. Okay? So, what is different from yesterday? Today I'm getting rid of the denominators. I'm not keeping them. That's it. Otherwise, you do the exact same process that you did yesterday. All right? Let's look at a second example now. 5x over x minus 4 plus 2 equals 3x plus 8 over x minus 4, right? Okay. So looking at my denominator right now, what do I want to get rid of?
Minus 4x.
4 minus x?
You have to do the illustration.
Yes, that's the first thing I want to do. What can x not equal?
4.
Okay, easy enough. All right, so I want to get rid of my denominator. Don't want the denominator. So what am I going to multiply everything by to get rid of this denominator? X subtract 4. Now, in rational expressions, I would multiply the top and the bottom by x minus 4 to get it, because I'm actually adding them together. But in equations, I'm just multiplying everything by the top. Okay? So I'm going to multiply this by x minus 4, this by x minus 4, and this by x minus 4. Okay? That cancels. What does it leave me with? 5x. 2 times that is 2x minus 8. And that cancels and leaves me with 3x plus 8. Everything to one side. So that's, move that 3x over. So it's 4x is equal to 16. 3x, so this is 7x here, right? 7 subtract 3 is 4x. 4x equals 16. I moved the 8 over and added it. What does x equal? 4. Are we done?
Yes.
Yeah?
No.
Why not?
Not equal 4. X can be compared.
So we call an extraneous root. You have to cross it out. There is no solution. Okay? So this is, in theory, a solution, but you have to make, say, the solution by putting a dotted x through it, because you can't have x equaling 4. It's the only thing it can't equal. So there is no actual numbers solution to it. The answer is there's no solution.
So if there was 2 numbers and one of them was 4 and a different number, you just cross the 4 out?
That's absolutely, yeah. All right. Now, okay, first of all, I'm not done here yet, because this is going to get yucky. Let's do a separate example. Because once we get into the problems, you're going to not like this. Already don't like it? Fair enough. Alright, so now, looking at this one here, I have 2 choices as to how I want to approach it. First choice is to multiply by each individual piece. The second choice is to multiply by a common denominator. Does anybody see what the common denominator is right away? What is it? No, we don't do that. You don't want to multiply it up, because I'm going to end up factoring it again.
Subtract 8 times x.
Right, that's it. Okay? Alright? So that's what it is. There's my common denominator. This is it here, right? Okay, so now we're going to multiply by that value. So I'm going to multiply this by x minus 8, x plus 2. This by x minus 8, x plus 2. And this by x minus 8, x plus 2. Okay, so what cancels in the first one? X minus 8. That cancels. What does it leave us with? X plus 1 times x plus 2, right? Okay, what cancels in this one? X plus 2. Now leaves us with 2x add 1, x minus 8. And all of it cancels and leaves me minus 7 here. How do I solve this? Tell me in two steps. How do I solve it? Okay, but what? How do I? All right. So there's the second step. Get it to one side equal to 0. What's the first step? FOIL it. Multiply it out. Whatever you want to say. You want to expand it, right? So we expand it first, then collect everything on one side, and then it's just simple factoring, which you did in grade 10. Right? Okay, so let's do this. So x squared plus 3x plus 2, add 2x squared minus 16 plus 1 is minus 15x minus 8 equals negative 7. Okay? And then get everything to one side. 2x squared and x squared is 3x squared. Right. 3x squared. 3x and minus 15x minus 12x plus 2, subtract 8 is negative 6. Negative 6 add 7 plus 1 equals 0. Does that look right to everybody?
So you follow both sides. So both.
What do you mean by sides?
Well, both. Like underside.
Yes. Yes. Foiling both of them. Okay? All right. Factor, go.
Factor is 3,
Mm-hmm.
but add 3 and 12.
Yeah. Michigan ahead of it.
That's impossible.
Sure is. Can't be done. You can't factor this. Okay? Right? 3 times 1 is 3. There's no factors of 3 that add give you negative 12. So how do I solve it then? If it's not factorable, I have to use the quadratic formula. Oh, boo. See how important it is to learn from unit to unit how to do things? X equals minus b. 12 plus square root b squared, which is 144, minus 4 times 3 times 1, all over 2 times 3. So 12 plus minus square root of, what's that, 144 minus 12 would be 132 over 6. Is there a perfect square that goes into 132? It's not a perfect square. Does 4 go into it? How many times does 4 go into 132?
33.
33. 12 plus minus 2 root 33 over 6. So again, what we do last unit, we worked with radicals. Doing it again today. So everything just keeps building on, building on, building on.
Let's not have any of those questions.
Now, if you look at it, I did question 2 on page, or sorry, 1B on page 268. It says, do not solve. All I wanted you to do is this. Right there. That's all I wanted you to do. But I wanted you to see what has to happen, because you are going to get into questions that you are going to have to solve for them. Okay? All right, we're going to spend today and tomorrow on, I'm going to go through the problems tomorrow on this 6.4. All right? I'm not going to introduce those today, because you're already at your max limit, I'm guessing, for capacity. So, questions from yesterday?